Okay, let's get to the question that they've asked. A says, was the number of employees increasing or decreasing at the beginning of 97? So please have this right in front of you because I'm going to have to take this away. Okay, again, it says the number of employees increasing or decreasing. So they're asking you to look at E, not E prime. So, although E prime can inform E. So look, I've sketched out E right here. And I also put the dates. If this is 81, that's 83, 85, 87, 89, and so forth. So please mark those on yours as well. For 1997, I got right here, and you can see from my graph of EOT that through 1997, E decreases, right? You can also see on this one, 1997, E prime is below the x-axis, so E should be decreasing. So it doesn't matter which way you use it. You should know that E should be decreasing at that particular point, right? So I'm going all the way back to your rules, code switching rules. All right, so let me show you B. B says, was the number of employees, this is E, increasing or decreasing at the beginning of 2001. So let's find 2001, it's right here. Right? One way for me to do it is to look at my sketch and I can see E is moving up, increasing. I could also look at E prime and say, oh yeah, E prime is above the x-axis, so my original function E should be increasing there. All right, so let me show you how I'm going to answer B. All right, so those are the answers. Okay, this goes back to code switching. I noticed that many of you did struggle with that particular quiz. Please learn the rules. You absolutely have to learn them. All right, so I'm going to come back and see it to C and D. I want to move on to E. E says, so this is where I am. At the beginning of what years was the number of employees the greatest? So it says the number of employees, this is E, is the greatest. So I'm going to look at my sketch of E. That's the beautiful thing about sketching it out. And they're asking, when did you have the greatest number of employees? Now the beautiful thing about the work that you've done is you can make comparisons now. Here you have 2,000 employees, then 1794, then 1843, then 1394, and then 2,196, which I think is the biggest one out of all of the things that I listed. So that's going to be right here at T equals 24 or 2005. So I would suggest just sticking with the T values. This is T equals 24. Right? You could put 2005 if you so desire. Right? Either is appropriate. So then F says, at the beginning of what years was the number of employees the smallest? Number of employees. This is E, not E prime, right? We have to look at our sketch. When was the E the smallest? So if we look right at our sketch, then we should be able to compare the numbers. Look, 2000 here, 1794, 1834. I believe this is the smallest one. So let me trace that to where that goes. Right there. 1999. Right, or T equals 18. So here I would put T equals 18 or 1999. All right, so let's move on to G. Okay, again, I'm assuming you're looking right at this, that you printed it out. Was the number of employees at the beginning of 87 more or less than the number at the beginning of 91? 87 and 91. So we'll go over here. Here's 87 right here. And there's 91. I'm gonna look right at E. And I'll say, wait a minute, 91's bigger, right? How do I know that? E prime is positive, which means E should be increasing that entire time. So 1991 yields more employees than at 1987. So let's see how we're going to answer that. 87 was less. Oops. Right. 87 had less employees than 91. Okay. Then H says at the beginning of 91, compare that to 99. 91. Let's see, where are we? Here's 91 and here's 99. Okay, notice E prime is negative, so E's decreasing. See that? Decreased by 449. So you should have more in 91 than in 97. Okay, so let's answer that. More in 91. So the beginning of 91, you should have more employees than in 1999. I'm sorry, I said 97, but I meant 99, right? Right here, 99, because that's where the next critical point would have been. So for C, was the number of employees at the beginning of 87 more or less than in 99? All right, so this is going to be interesting because notice we don't have a simple arrow going up or down. Here's 87 and here's 99. Okay, from 87 to 91, notice you went up 49 employees, right? You can see it right there. But then you dropped 449, right? You either fired them or they left, right? So you should have fewer employees by 99 than you had at 87. Look, you can see it on your graph. Yeah, you went up 49, but you lost 449. So there should be more at 87 than at 99. So here, that's how you answer that one. Like that, there should be more at 87 than 99. All right, so Jay says if the number of employees in 91 was 2,000. So obviously, I didn't have 2,000 employees to start off here, right? So I just happened to use that particular number. It was kind of convenient for me. So what they're saying is that you actually have 2,000 employees in 1991. It says right there in the problem, 1991. So let me put that right here. I'm going to put a star next to it, right? So you actually have 2,000 employees here. So these numbers here are inaccurate, but they still brought us to some very interesting conclusions, right? That we could use to answer the question. So they're saying if you start off with 2,000 employees, then how many do you have in 1999? So you start off with 2,000 here, and they're asking you by this point, how many do you have? Well, you start off at 2,000. You decreased 449, so this should be whatever 2,000 is minus 449. So 2,000 minus 449, right? So what is that? Hold on, 1, 2, 3 minus 449. 1,551 employees. 1,551. Okay, so notice what my J says. How do I keep writing down the wrong numbers? This is 1551. 1551. And then K says if the number of employees at the beginning of 91 is 2,000, then how many were there in 2005? So let's see. They're telling us that you have 2,000 here. This is 2005. So notice you lost 449, but by 2005 you'd gain 802. So what is that going to be? Well, it'll be 2,000 minus, 449 plus 802, right? You lost, but you gained. And I got 2,353 employees. So right here we have 2,353 employees. Okay, please make sure you put units on it as is appropriate. Okay, so then D says, I'm sorry, it's not D. What is this? HIJK. This is L. What's the total change in the number of employees from 81 to 2005? All right, I want to show you both the mathy way of writing it. You can actually see it here. You lost 206. You gained 49. You lost 449. You gained 802. So one way to do it is to write it in numbers, right? So you could write minus 206 plus 49 minus 449 plus 802 employees, right? But if you were to write it in a mathy way, then you would have to acknowledge that this is basically just the region trapped between the function and the x-axis, starting at x equals 0, ending at x equals 24, right? So the mathy way of writing this is this. the integral from 0 to 24 of e prime of t dt, right? Because your region is trapped between this function and the x-axis, starts at x equals 0, ends at x equals 24. All right, a couple more problems and then I'll call it quits from there. And that is going back to letter C as in cat. So this is where I am. And D as in dog. Okay, please have this in front of you so that you can see how it reads. C says, at the beginning of what year was the number of employees decreasing the fastest? This is a tricky question because you actually have, this one says, oh yeah, you're decreasing, but you're decreasing the fastest. So it's like saying, look at your derivative function because you're looking at the decrease of a decrease, right? And then here, this says, when is the number of employees increasing the fastest? So let me compare what I had up here. In letter A and B, it just says, where's your function increasing or decreasing? In which case we could look at E. But here it says, where's the number of employees decreasing the fastest, which says you need to look at E prime. So, and this one too says, look at E prime. So what they're asking you to do is, for the very first time, look at how E prime is behaving, and you're trying to find out where you have your greatest E prime. So if I look right at my graph, for the very first time, I can look at its appearance and say, I have the highest E prime right here at about 22, right? So that's where we would expect E prime to have its greatest value. So that would be the answer to D. This is t equals 22, right? And then the other one says, when is E prime at its least value? And I would say that's somewhere in here. Kind of hard to see it, right? The lowest E prime is about t equals 15. I'll let you guys change those to specific dates. All right, so that takes care of all of those questions. If you have any concerns, please shoot me an email.